Okay, hello everybody and welcome back to my channel. And on the bench today we have one of these little NAM NAP 250s. Now this is another rip-off of a British company, NAM, and this is the particular clone I have in my hand. This is the second channel. It's not built up yet, so I've not done a listening test on this. And as you can see, this is the one with the little panda bear on there. And if I just flick it over, we will see that it's the NAM NAP 250 modified version 4. Little panda again, and it's the LJM _LJM at foxmail.com. 2004, 2021 LJM. Okay, plus and minus 40 volts to go in, or you can use other voltages, and that's something I'm going to show you today as well. I've actually got it set up here at the moment for 13.5 volts. I was just thinking to myself, well, what if you can't, what if you don't have a power splice or one of these from using a couple of car batteries or a couple of leisure batteries? And so we say those leisure batteries around about 13.8, charged, and 13.5, just a figure I've come up with. So let's just have a quick peek at the actual board. Now I'm just going to click onto my orders here. This is some I ordered and bought back in 2023. And I'm going to click on here. Just take note, A5-013. That's the kit here. So when I click on here, you'll see here it says A5-013 again. But you may notice some, and I'll let you do this in your own time, that there are some modifications. If I just show you this, and then you look at that board, on there you'll see that we have some modifications, polystyrene film, polypropylene, I can't remember what they are, but it's a film capacitor, and there's another one there, and this has changed from a ceramic to this multi-layer, and also the capacitor here and the LED have swapped over, which is interesting. Okay, and if I just go over to here where it's this get off this Ayama, I don't know how to say it, I'm really sorry. You'll see that that is exactly the same board as what I'm going to be looking at now as a reference, but there's just something noteworthy down here. It says here, AIM NAP 250's mod is LJM's imitation of NAP 250 and an improved version. So this is LJM's imitation, and so I'm going to assume then that this board is a better version of that. We don't have the panda, look, on here. So let's go back then, and there's something else interesting here. Better performance than NAM NAP 140 and 200 comparison. All LJM products do not provide circuit diagrams. Please don't buy. So there's obviously some, some competition going on here. But look at the THD noise here. Yep, 0.001%. All right. And funnily enough, LJM is the outputs that they're given. And I just wanted to point this out as well. So this is our frequency. It should be from, presumably again from 20k, 20 hertz. I don't know. On this scale, but here's 2k, 4k, so all the way up to 20k, and here's our THD noise scaling. So we can see it starts off here at the lowest. It starts off at 0.002%, and all the way it just rises up until about 10k. Where we are at the lowest number there is 0.01, and then it drops down and it gets to about 12.5, 13k, and on the lowest one, I'm not going to go through a lot of them, it says it's at 0.01, and that follows the trend across here. The highest one is 0.023, and that follows across there. But it's just interesting that the LJM audio LJM audio again. Right, that's just, it just made me laugh a little bit, because they're having a go, LJM audio, and they're using the outputs for their own reference, and so is this one here. Not that I can see that they're having a go at LJM audio, and it's all basically the same on the scaling here, apart from this is the volts dB. This is for against the frequency it says, but it's a different, it's actually a different scaling down there, but never mind, doesn't matter, because we're going to look for ourselves anyway. Again on this one, 0.001%, but we're going to just look at it very quickly now with 3 different voltages. Alright, I'm going to go for the full voltage that I can on my power supply, clear as close to plus minus 40 as I can, and I'm also going to do, starting off with what we've got in here as 13.5. Alright, so let's give this a go then, and as you can see on here, you'll see that my, if I get this on the right bit, that, well, yeah, I've been playing around with this for the last couple of hours, so on there at the moment it's on 97% of my volume. Not that it's going to make any difference here, because when I switch over to this now, and we're doing that, and we're doing it here, you can see that the current goes up that we're using to 0.7, let's say, amps, and our total harmonic distortion is 0.00098. We just take that off there for a second and we look at, just turn it off, so we just got to capture on the screen. Total harmonic distortion is 0.001 plus the noise 1%. Getting close to the 2 with the 9 there, but never mind, that is still the 1%, right? And we're at minus 3 dBFS. Now let's quickly look at the frequency response at this voltage. Oh wow, it's way out. Okay, and it's going to capture beautiful. Let me get this the right way around. Oh, come here, I can't get my finger to stay still. Alright, it's not going to do it that way. And so we can see here, this is a point scale, so it's not even going to 2 dB here. We can see that on the 430, 0.06. Now, you don't have to remember this because it all looks pretty the same as what it does at the other voltages, and on here it's 0.04, but that's the minus is here, of course, and it's a positive here, even though it's not saying positive. We're just going to accept that as a positive. It looks a bit different to the outputs that you see here, which, let's go down a few more. Let's go, here we go. We see here it's you know, it's not dropped off a lot, but here it seems to be quite different. We seem to be coming across and then dropping off here. Well, I don't know which actual of this actually goes with which of these boards, because as you can see with the other board, I mean, this is the other board, what they're using. You know, that's just one of the things, isn't it? So it's all right then. Let's go back to the spectrum analyzer, and I'm going to turn this voltage up now, and we're going to go to let's say 24 volts, because that's another one if you're in a truck or something. 21, 25, so say 24 and a half. Yeah, or if you joined, you know, if you had a whole bunch of batteries or something. It's only to see what it's going to look like. Can't remember exactly what it was, 0.000. Well, anyway, who cares? Let's go back and let's have a look at this now. So now, if I just do a capture there, hold that, we can see here the total harmonic distortion at this voltage. Oh, let's just do a quick look at how much current we're using. 1.254, which is pretty much doubled up because we've doubled up on the voltage, nearly. And yeah, so we got a total harmonic distortion 0.0013 plus the noise 0.0021. Very good still. So that's the full scale I can put into it, this calibration. And let's look at the highest peak here. So the highest peak here is about 3K. And if I can get my thumb to stay still, I'll move that out of the way. There we go, minus 105.34. -107, so we go to the lowest or the highest number, depends how you look at it, the -105. Okay, which is very, very good, because that means that we are 100 dB down from our fundamental input, 100 dB down, so that's very, very good. Now I'm going to do it at the full voltage that I can. So now we're at our full scale of 31, well, it's 32 volts basically. All right, so we'll see what we get there. We'll look at the current being used, 1.6 amps, and we are, I may as well just save that across there now. THD 0.0015. It's it's all very, very close, isn't it? So I'm just showing you that even on those different voltage inputs, it's all very close, and I wonder if it's going to be any better or any different if we were up ±40. That's basically what I was just trying to sort of show. Of course, we don't know. I can't go to ±40, but we can get sort of an idea. Let's take a peek at our frequency response. I know I didn't do it on the last one, but there's no point really. Because this is going to show us everything that we need to see. We're going to see again, here's the 0 line, and I think we were -005 here, weren't we, on 30, 0.06, -0.06, brilliant. And over here we were a +4, round about there, 0.04, so it's, yeah, the same. So the frequency response isn't really affected by the voltage either. And there is a little bit difference to this setup and the setup I used before. Now I've checked this and it doesn't make any difference whatsoever, it seems, and that is with what I'm using here as my probe. See, before I was using this attenuator cum voltage clamp as a probe. Yeah, and this is what I got from the Arta website. I've just built it exactly to their setup. And then this one here is rather simpler. Again, voltage clamp, and rather simpler. And this is, I've seen this circuit before, but this is on John Audio Tech shows this circuit, and that he's a pro, and so I thought, well, I'd give that a go as well. And I've run the tests as well, using both of them. I can't actually see any difference. So, one or the other is good enough. This one is simpler. These are, in order to, I didn't have a 1K resistor that was like, let's say, half a watt or anything like that. So what I've done is I've used 3.3s K resistors in parallel, which makes that around about 1K resistance. And of course it can handle some extra warmth going through there, because there's 3 of them. And this clamps down to around about 2.5 volts, even if I stick 30 volts into that on the output of this off the dummy load. Then we'll only have 2.5 volts, which means I'm not going to be clipping on the input of my line in on the sound card. All right, well, that's it. That looks pretty good. I may or may not get one of the other boards that has the updated modified version, not JLM, but uses his scaling and his output on their advert, which is funny. And if I do, I will show you what it's like. But I will do some listening with this and see what it's like, and I will give you what I consider to be as unbiased and subjective review. Well, I don't know, but that's, I will do it as unbiased and objectively as I can. And yeah, and let you know what I think. If you got this far, thank you very much for watching, and I will catch you in the next one, guys. Take care for now. Bye bye.